Dear students, today we can solve some of the problems using the equations of motion. Example 8.5. A train starting from rest attains a velocity of 72 km per hour in 5 minutes, assuming that the acceleration is uniform. Find. The first question is the acceleration. The second one is the distance traveled by the train for attaining this velocity. In this example, we have to find the acceleration as well as the distance traveled by the train. So here, the train is starting from rest. Wherever you find the rest means the train is not moving, isn't it? Then what will the velocity or speed of the train? That will be obviously 0. So we have to take the initial velocity as 0 because the train is starting from rest. So the train is starting from rest. So the initial velocity means the starting velocity of the train. It is represented by u. That's equal to 0 km per hour. If we convert the 0 km per hour into meter per second, we will get the 0 meter per second. So I have written u. Now the train started to attain the velocity of 72 km per hour. Velocity of speed 72 km per hour. See, here we have to find the acceleration. Whenever you find the acceleration, you must take the readings in meter per second. Meter and second. So here we have to convert 72 km per hour into meter per second. How will you convert kilometer per hour into meter per second? We have to multiply the quantity given in kilometer per hour by 5 by 80. So 72 km per hour equal to 72 into 5 by 80. That much meter per second. Isn't it? So we can cut. For 5 that's equal to 20 meter per second. So we got final velocity. Attained velocity, final velocity, that is represented by v, that's equal to 20 meter per second. Now, and the one more quantity is given in the question, that is time t equal to 5 minutes. Here the minute is not as a unit of time, so we have to convert into second. So I will convert 5 into second, 5 into 60 second. 60 second, that's equal to 300 second. Now we got all the quantities. Our first question is to find the acceleration of the train. So we can write the acceleration of the train by using the equation a equal to what is the equation to find acceleration? Final velocity. Acceleration is the change in velocity divided by time. So final velocity minus initial velocity by time. So what is final velocity? V minus u divided by t. After writing the equation, we have to substitute the values. That are 20 minus what is initial velocity? 0 divided by, then what is time? 3. Okay, 300. So our answer is 20 divided by 300. We can cut 1 zeros, then the remaining is 2 by 30. Again, set even number, we can cut with 2, then we will get 1 by 50. What is the unit of acceleration? That's meter per second square. Meter per second square. So we got the answer for the first question. Second question is to find the distance traveled by the train during this time interval, that is 5 minutes. In 5 minutes, how many distance is covered? That's our question. See, we have written the three equations of motion here. V equal to u plus at, s equal to ut plus half at square, and third one 2a is equal to v square minus u square. We have to find s. See, in this equation there is no s, so we can skip this equation. Here s is there and u, we have u, t, half, a and t square. All the quantities are given in the question, and one quantity is also we could find. So in this also 2a is equal to s is also here. So these two equations are possible to calculate the distance traveled by the train. So which will be easy for you to calculate here. 2a is equal to v square minus u square. If you use this equation, it will be easy for you to calculate this one because the square thing ut plus half at square. We can use these two equations, but if you use the third equation, that will be easy for you to calculate. So the distance traveled. Equation from third equation we have to calculate 2a is equal to v square minus u square. We have to find s only. Therefore, s equal to what will be equation? V square minus u square divided by here 2a is extra term, so we have to take this 2a into the right side, then it will come to downside. So 2a Now substitute the values. What is V? V equal to 20. 20 square minus what is U? 0 divided by 2 into what is A? A equal to 1 by 50. 20 square equal to 400 divided by 2 into 1 by 50. So we can apply the A by B divided by C by D formula. So 400 can be 400 by 1. Then how to calculate A by B divided by C by D? A by B into D by C. A by B 400 by 1 divided by 2 by 50. Okay, so how to convert 400 by 1 into 15 by 2, reciprocal of this one. 15 by 2. Now we can cut down. Then what will be the answer? 200. 2 into 15, 3. 30. Then 3,000 meter. Since all the quantities are given as a unit, then our unit will be meter. 300 meter equal to, we can express in kilometer also. 1 kilometer equal to 1000 meter. Then 3000 meter equal to 3 kilometers. So the distance traveled S is equal to 3 kilometers. If you get the confusion over here, then I will explain. A by B divided by C by D. That's equal to A by B into multiplied by reciprocal of this one, D by C. See, whenever you get these types of fractions, you have to multiply with reciprocal of the denominator. So we got the answer for the first example. The acceleration of the train is 1 by 50 meter per second square, and distance traveled by the train is 3 kilometer or 300 meter, 3000 meter. So we have to solve the problem how I have solved this video. So I won't give the PDF for this one. Next example, example 8.6. A car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the first one, the acceleration, and the second one, the distance covered by the car in that time. This example is same as the previous one we have solved here. First, we have to write out the quantities given in the question. So in this question, a car uniformly accelerates from 18 km per hour to 36 km per hour in 5 seconds. So the time we have to note out the quantities given in the question. The initial velocity u equal to 18 km per hour. See, this is not in SI unit, so we have to convert into SI unit. What is SI unit of speed? Meter per second. So we have to convert into meter per second. Multiply the quantity given in kilometer per hour by 5 by 18. We can cut down this 18 and 18. Then we will get 5 meter per second. Similarly, we have to convert the final velocity, that is 36 km per hour. Into meter per second. So 36 into 5 by 80 meter per second, isn't it? 18 into 36, that's equal to 2. Then 2 into 5, 10 meter per second. So we have converted all the quantities into SI unit. The third quantity time is only given in SI unit, that is 5 seconds. So no need to convert. Now we can solve the first part, acceleration. The first one is to find the acceleration of the car. Acceleration is given by the equation v minus u by d, change in velocity by time. Now substitute the values. 10 minus what is u? 5. That much meter per second divided by 5. 10 minus 5, that's equal to 5. Divided by 5. Second, then our answer will be 5 by 5, that's equal to 1 meter per second square. So we got the answer for the first one. Now similarly we can find the distance traveled by the car. Here three quantities are there. We have three equations are there. In order to find the distance, we need not to use this equation because S10 is not there. And two equations are there. Here S is the U and U is the T is the half, all the quantities are given. So this is possible one. And here also all the quantities are given. So this one is also possible. Then this will be easy for you. Better use the third equation. Since these two equations are possible, but this would be easy for you to calculate. So use the third equation. So the distance traveled 2as is equal to b square minus u square. Therefore s equal to b square minus u square divided by 2a. See, if you use the second equation also, your answer will be correct, but better use the third one. What is b? 10 square minus 5 square divided by 2a. 2 into 1. 100 square, 100 minus 25 divided by 2, that's equal to 75 divided by 2. So our answer will be s equal to 37.5 meters. Example 8.7. The brakes applied to a car produce an acceleration of 6 meters per second square in the opposite direction to the motion. If the car takes 2 seconds to stop after the application of brakes, calculate the distance it travels during this time. In the last example, we had to calculate the distance traveled by the car. See, car is moving with an initial velocity, constant velocity. It's not mentioned in the question. So, then suddenly the driver applies the brake. Then the car stops. See, I have represented this situation as in the figure. The car is moving with the initial velocity u. Suddenly, the driver applies the brakes to stop the car. So, what is the final velocity? And final, the car is not moving. So, final velocity will be 0. So, I have written the final velocity be equal to 0. And in order to stop the car, an acceleration is applied in opposite direction. See, here the final velocity is more than the initial velocity. So, what is the equation to find acceleration? A equal to b minus u divided by b, isn't it? Here b is a smaller than u. So it will be a negative value, isn't it? So this indicates if v is smaller than initial velocity, if the final velocity is smaller than initial velocity, then the acceleration is said to be negative and it's called as deceleration. So it has to be represented by negative sign. Acceleration a equal to minus 6 meters per second square. The reason is here why we have put the negative sign. It's a deceleration, negative acceleration. Why? The initial velocity is greater than final velocity. Final velocity is 0, and when the car moves, there will be a value for the initial velocity. So it will be always greater than 0. Then time is also given 2 seconds. Our aim is to find the distance traveled by the body. Here, two equations are there to find s. These two equations are possible, isn't it? Here, but the problem is in these two equations we need u. Okay, so these two equations are possible, but before solving the problem, we have to find u. In order to find u, we have to use this equation. Here, a is given, t is given, p is given. So, why we have to find u? So, first we have to calculate the initial velocity from first equation of motion. What we can write? What is first equation of motion? P equal to u plus a. Therefore, initial velocity u equal to, we have to find u, so we can take these terms to this side, b minus at. How we are taking this one to this side and we will remainder, so u equal to b is already there, so just we have to write b, then this plus signal comes to negative sign to this side and it will be negative b minus 80. Now substitute the values. What is b? T equal 0 minus, what is a? Minus 6 into t equal to 2. Then this is given positive, minus into minus positive. 0 plus 6 into 12. So what is the answer? 12 meter per second. So we got initial velocity as 12 meter per second. Then we can calculate the distance. See, you can use these two equations, both are possible, but in the previous two questions we have solved the questions with this equation. Now we can use this one. It's your choice which equation you have to use. Then s equal to ut plus half ab square. What is u? We got 12. 12 into, substitute for t equal to 2 plus half into A equal to minus 6 into t square 2 square. So we ended up with in brackets. Then 12 into 2, 24. Here one minus sign, minus into plus, this is minus. Then what will make here 1 by 2 into 6 into 4. So we can cut this one. 2. Then 24 minus 6 into 2, 12. So what is the answer? S equal to 12 meter. So what we are getting, the car reaches rest, the car stops after applying the brake, and within 2 seconds it will move 12 meter and comes to rest. That is when he applied the brake, within 2 seconds the car moved 12 meter and comes to rest. Similarly, this is one method. Otherwise, you can use this equation, that is S equal to v square minus u square divided by 2a. If you have doubt, you can substitute 0 square minus what is u square, that is 12 square divided by 2 into minus 6. 12 square, that is minus 144. Otherwise, we can write 12 into 12 minus 12 into 12 divided by minus 12. So we can cut 112 minus 12 meter. This one is also possible. Okay.